Today we will start vibrating string, that is the PDE, partial differential equation governing the vibration of given strings. Okay, so conditions are we are considering the transverse vibration of a elastic string such as like violin string, etc. Okay, what we are doing here is we are placing the string along the x-axis and stretch it to length L, and the string is fixed at both ends, x equal to 0 and x equal to L. And suppose that if you are pulling the string back and if you release it at a time t equal to 0, it started vibrating. So the equation governing this motion of vibration is known as wave equation, and it is given by dou square y by dou t square equal to c square into dou square y by dou x square. Here y of xt is the displacement of the vibration at a time t and position x. Okay. It has a boundary condition y of 0 t equal to 0 and y of L t equal to 0, and with the initial conditions are initial displacement and initial velocity. We know that initial condition means it is the value of function at a time t equal to 0. So we have y of x0 equal to f of x, and dou y by dou t at x0 is equal to g of x. Okay, so f of x is the initial displacement and g of x is the initial velocity. So as I told in the heat equation, we solve this by separable method. So we'll separate the solution as x into t, and we'll find the the second order differential equation satisfying this wave equation. And I told you we'll discuss in three cases where the this constant is equal to 0, the constant is positive and the negative. And as we discussed in the heat equation, the cases for constant equal to 0 and positive will give you trivial solution, y equal to 0, that we don't want, we are not interested, right? So in that case, the case when the constant, the ratio is negative is we want, and after substituting all those values of initial conditions and boundary condition, finally we'll get the solution as y of xt is equal to c1 cos n pi by lct plus c1, not c1, actually it is cn, because using the method of superposition we'll get the solution like this, right? Sigma cn cos n pi ct cos n pi by l ct plus dn sin n pi by l ct whole into sin n pi by lx. Okay, so you should keep this equation, remember y of xt is equal to what? Sigma cn cos n pi by l ct plus dn sin n pi by l ct. This is the term whole into what? Sin n pi by l x. This is the solution, and after substituting the initial and boundary condition, you will get cn is equal to, that is to be noted, cn is equal to what? 2 by L integral 0 to L f of x into sin n pi by lx, and dn is equal to, that is should be noted, that is 2 by n pi c integral 0 to L g of x into sin n pi by lx dx. Okay, so that is the solution, and cn and dn are the constant. Cn is 2 by L integral 0 to L f of x into sin n pi by lx dx. Okay, and dn is what? It is 2 by n pi c integral 0 to L g of x into sin n pi by lx dx. So these two equations you should note. Now we will go directly to the problem, because that is very important as far as we exams are concerned. So let us see the problem. This is the first one. A stretched string, a tightly stretched string with fixed endpoints x equal to 0 and x equal to 10 is initially at rest in its equilibrium position. If it is reset vibrating by giving to each of its points a velocity 10x minus x square, find the displacement of the string at any distance x from one end at any time t greater than 0. So read the question well. So we have a tightly stretched string with the fixed endpoints. So that means with the fixed endpoints x equal to 0 and x equal to 10. That means the length of the string is x equal to 10, and it is also given that it is initially keeping equilibrium position. It is at rest in its equilibrium position. So our string is like this, right? At the equilibrium position is like this. So this is 10, this is 0. So then we are giving a velocity and make it as vibrating. So this velocity is 10x minus x square. So what we are getting from this, that this is we want to find the displacement of the string. So that will this solution is connected with the wave equation, and you should write the equation governing this problem is what? Wave equation. And you should write the wave equation, that is y tt is equal to c square y xs with the initial condition y of 0 t equal to y of l t is equal to 0 and y of x 0 equal to f of x and dou y by dou t. Okay, dou y by dou t x 0 is equal to what? G of x. So g of x. So you should write this first. Okay, then you should write the solution. What is solution? Sigma Cn, that equation, no? That equation you should write, and what is Cn and what is Dn you should write. So this is the first part of this problem, and then you should identify what is your L, what is your F, what is your G in this equation, right? L is what? L is 10. So it is already given. Okay, and what is f of x? I told you the string was initially kept at rest, so initial displacement should be what? 0. Then we applied a velocity 10x minus x square, means that is the initial velocity. So you should write gx equal to what? 10x minus x square. Then we have to substitute the value. Clearly Cn is 0 because f is 0, right? So Cn is equal to 0. Now we have to find Dn. Since gx is equal to 10x minus x square, you should write Dn equal to what? 2 by n pi c 10x minus x square sin n pi by 10x dx. I told you generalized integration rules you should write. So first you should write what? 10x, sorry. First I told you should write 10x minus x square, then its derivative 10 minus 2x, then again its derivative minus 2. You should write here our second function is sin n pi by 10x, right? So its integration you should write. What is its integration? Cos n pi by 10x, its derivative by n pi by 10, its derivative is minus sin n pi by 10x by n pi by, it's not derivative, it's integration, square, again cos n pi by 10x by n pi by 10 whole cube. This is the equation. So you should multiply these two, right? Then you have to subtract that one, then you should multiply these two, then add it. Okay, so when you multiply these two means sign will be minus. When you multiply these two means it will become positive, because here it is negative, here also it is negative. So it will become positive. And in this equation when you multiply these two, this is negative, right? So negative into positive is what? Negative. So that you should keep what alert. Okay, so that is I have done here. Okay, then you have to apply the limit. So when you apply x equal to 10 initially, you will get to see what you will get. This limit will be 0 because it is 100 minus 100. So it will be 0. And here no, you will get you will substitute 10 here even though. But you know that when you substitute here 10, sin n pi by 10 into 10. Okay, so if this 10 and 10 cancel, you will get sin n pi, and sin n pi is what? 0. Okay, now similarly cos n pi by 10x, in this case when you substitute you will get 10 will be cancelled out, you will get cos n pi, and cos n pi is what? it is minus 1 raised to n, right? Then minus, you have to substitute x equal to 0. So this term will be 0, this term will be 0, finally you will get this term only. So substituting all those value and simplify, you will get like this. Okay. Next is what is our next problem? This is the next problem. So I am not explaining detailly because just we have to identify what is fx and what is gx and substitute and use the generalized integration rule. Okay. So in this question, the ends of tightly stretched string at a fixed endpoints x equal to 0 and x equal to L. At t equal to 0, the shape of the string is defined by f of x equal to kx into L minus x, where k is a constant. And if the string is released from the position, find the displacement. So in this case, note that our string is of length L, arbitrary length L, and the shape of the string was initially, time equal to 0 means initially, right? So in that case, the shape of the ring was what? F of x equal to kx into L minus x. Note that here it is given fx. So that will help you to get you that it is the initial displacement, right? So, but not that if it is not given as f of x, but you should see the sentence, read the sentence well, because the shape of the string was kx into L minus x means at a time t equal to 0 means what? That is the position of the string, right? So it is the initial displacement of that string. So what is the initial displacement? Kx into L minus x, that is f of x. Then the string was released from the position though. So the string was what? Initially it was thrust. Okay, so the initial velocity should be what? It will be 0. Okay, so here gx equal to 0 and fx equal to what? Kx into L minus x. So clearly dn will be 0 because d is 0, right? And we have to evaluate cn. I also done that problem and I'll get this like this. And the last problem is, that is also different one. What is the last problem? The last problem is a tightly stretched string of length L has its endpoints x equal to 0 and x equal to L. So same as in the earlier problem, we have a tightly stretched string of length L, and then the midpoint of the string is taken to a height h and then released. So midpoint of the string we have taken height like this and we released from this position. Okay, so what is your initial velocity? What is your displacement? So released from rest means the velocity should be, initial velocity should be 0. So g is 0. So what is the initial displacement? Is it 0? No, it never, because if both the initial velocity and initial displacement 0 means our value will be 0 only, no? So what is your initial displacement? So this is the initial graph of your initial shape of what? Our string. So what is this point? This is 0, 0, right? What is this point? This is the midpoint, right? This is the length L. So midpoint means L by 2. So this is L by 2 h and this is L 0. So our initial displacement is of this shape. This is the joining of two straight line. First straight line is this one. It is the straight line joining 0, 0 and L by 2h, and this is the second straight line. It is a straight line joining L by 2h and L 0. And we know 2-point formula to evaluate the straight line of equation joining 2 points, and using that you will get two equation, so that our function will become like this. This is the initial displacement 2h by L x for 0 less than or equal to x less than or equal to L by 2, and 2h by L L minus x for L by 2 less than or equal to x less than or equal to L, and g equal to 0. And again we have to evaluate the displacement as usual. So in this case you should note that our function is f is a splitted function, so your integration also should be splitted one, so you have to do accordingly. Okay, so this detailed answer should not be do directly, you can do the answer. Okay, so let me know if you have any doubt on this. Tomorrow I'll be there in the class. Okay, thank you.